Alright, imagine this. A liquid so cold it's almost unbelievable. At minus 162 degrees. We're talking about liquefied natural gas, or LNG. Now, what if we had to move millions of gallons of that across oceans, safely storing it, converting it, and sending it all the way into the national grid? Sounds complicated, right?
Definitely. And it's not just about bringing it in. It's a whole system, from offshore platforms to onshore facilities. It's a massive operation that requires precision, coordination, and a lot of technology working together.
Yeah, and today we're diving into how an offshore LNG receiving terminal operates. It's a crucial part of how LNG makes its way from ships into the grid, and every little part needs to be in sync for it to work smoothly.
Right, so first things first, these terminals aren't just one giant structure. They're a network of different facilities. You've got the offshore components, which then connect to onshore facilities.
Exactly. The offshore setup includes things like the LNG jetty, the FSU, and the regasification platform. They all play a key role in making sure the LNG is safely transferred, stored, and converted back into gas.
The FSU is particularly interesting. It's a floating storage unit that acts as a buffer, storing LNG until it's ready to be regasified. It's like a giant thermos, but it's crucial for maintaining a constant flow of gas.
And once the LNG is stored, the next step is regasification, right? That happens on the offshore rig, where the liquid is heated and turned back into gas. Then, it gets sent through a pipeline that runs underwater all the way to the onshore facility.
Yes, and that pipeline is key. It's a huge, robust structure that carries the regasified gas from the offshore platform to the land, where it's processed and measured before entering the national grid.
But it's not just about moving the gas. Everything has to be powered. Offshore and onshore facilities rely on electricity, water, and compressed air systems to function. Redundancy is critical here because, well, we're dealing with flammable and cryogenic materials.
Absolutely. Power is provided through electrical houses on both the jetty and the regasification platform. And even the floating storage unit needs power from the shore to avoid running its own generators constantly.
And if the power goes out, that's where emergency backup systems kick in. Offshore, there are emergency diesel generators that automatically start up to keep the safety systems running.
It's like a backup for the backup. The whole system is designed to ensure that even if something fails, it won't affect the operation. Everything has its fail-safe in place.
So let's break down the whole transfer process. Ships arrive at the jetty, which has special hooks to moor them. Then, the LNG is transferred through these complex marine loading arms that have to adjust constantly due to the ship's movement and the cold temperatures.
And those loading arms? They're engineered to handle both the physical movement of the ship and the cryogenic temperatures. The LNG is then transferred into storage, and any boil-off gas is handled carefully, using compressors and recondensers to recycle it back into the liquid.
Wow, this really highlights how intricate it all is. But we can't forget the critical safety systems in place, like fire detection, gas monitoring, and emergency shutdown systems. They ensure that everything runs safely, even in high-risk conditions.
Safety is the foundation of it all. It's a multi-layered approach. From fire suppression systems to automated shutdown procedures, everything is designed to mitigate risk at every stage. And this is something most people don't think about when they turn on their gas at home.
Exactly. It's a hidden marvel of modern energy infrastructure. All those moving parts and systems are what make it possible to deliver the energy we use every day.
And it all comes back to the information systems that guide the operation. How is data delivered in real time, and how does it ensure everything works together seamlessly? That's something worth considering.
For sure. So, next time you use natural gas, you'll have a whole new appreciation for the complexity and precision that go into getting that energy to you, safely and reliably.
It's like the ultimate balance of engineering, technology, and safety. everything working together to keep the lights on and the gas flowing.
That's it for today's deep dive. Hope you enjoyed the journey from ship to grid. Stay curious.